Hi, today's lesson is going to be on calculating area. I am a tutor for the Seeds of Literacy program, and my name is Ann Scanello. The lesson today isn't directly from any of the Seeds of Literacy packets. A good portion of it is from the geometry packet, but all of the geometry and algebra packets have got geometry kind of stuck in there for review to continue the other lessons. So these skills should help you with many of those packets. I'll go ahead and get started. What is area? People get confused. There's something called perimeter and something called area, and they both deal with geometric shapes, two-dimensional geometric shapes, which means that it's a shape that's flat. There's, it's not a three-dimensional item. But we've got perimeter, and that means the distance around the shape. And area is actually the measurement of how much area is inside the shape. The technical definition is the area of a figure is the number of square units that cover the surface of the closed figure. So we need to talk about square units, and what does that mean? A unit would be a unit of measure. It might be a centimeter, it might be a millimeter, it might be an inch, a foot, it could be a mile. But when you're measuring area, you're not just talking about a foot or a mile. You're talking about 1 foot squared, or a square foot, or a square mile, or a square centimeter. The pictures over here to the left are designed to show that. So that looks about like a centimeter to me. So 1 unit squared or 1 centimeter squared would look something like that. So this square would be measured in that size units. So that would be 4 of the square centimeters squared. This larger square would actually fit 16 of the centimeters squared like that. Now, unfortunately, not all shapes have got right angles or corners. So instead of just being able to count the number of square units inside a shape, we rely on formulas to help us calculate area. This is a copy of the GED formula page. So we're going to be talking about a lot of formulas for area today. And I just wanted to remind you that you will actually have a list of those formulas when you're taking the GED test or any other type of test. It's customary that these formulas would be provided for you. I like this version of the formulas because it includes an example or a picture of what that shape looks like. So we've got the square, shows us what a rectangle, a triangle could look many different ways, and a circle. Now, there was a note that was in one of the packets that I thought was really helpful and a really important piece of information. And we're going to talk about it throughout today's lesson, but I just wanted to kind of introduce it now. It says, in each case above, because you can see that the formulas are right over here, the height that appears in the formula is a line perpendicular to its base or its extension. And then it says perpendicular lines meet at right angles. So you can see the triangle formula has a height. The rectangle, we actually call it, this distance could be referred to as the height. They're making the point that it must be a line that is perpendicular to its base. But like I said, we'll talk about that more in a minute. Here are some more of the formulas. We've got the parallelogram formula. We've got the trapezoid formula. And again, both of those have the height in the formula. And so they remind us that the height must be a line perpendicular to the base or its extension. So what does perpendicular mean? That's pretty important to our lesson today. Perpendicular are any lines which meet or cross at a right angle. So you can see, and when you've got perpendicular lines, it's customary to kind of finish out the square. Put that symbol to show you that those lines are perpendicular. That angle would be 90 degrees. So that's an example. And then here's another example. So let's jump right in. The area of a rectangle, I actually skipped over the area of a square because the area of the square and the area of the rectangle are basically calculated the same way. The formula is area equals length times by width. And then they show you over in the picture, the bottom is the length, the height is the width. And a teacher once told me that length means the longest distance. You don't have to consider the longest distance the length, but it's just to be consistent, it can be helpful. Either dimension of the rectangle or the square could be considered the length or the width. The most important thing is we're just multiplying those two measurements. So let's go ahead and fill in some units here. So for our rectangle to the right of our screen, it is 3 units tall and it is 4 units wide. So the length would be 4 units. So in order to calculate the area, we could count those square units, which are printed there, or a more quick way would be to multiply the length times by the width to get the answer 12. But 12 is not the final answer here. Whenever we're talking about area, you've always got to include your units. And so anytime you have units for area, you have to remember you can't just say 12 units for this one. That area refers to units squared or square units. Okay, now the area of a triangle. The formula for the area of a triangle is area equals 1/2 base times by height. They're telling us now that B is the base and H is the height. Very similar to what we looked at with the rectangle. We've got the base would be the bottom here, and then the height would be the distance going up. In addition, we have the 1/2 symbol there. So we're taking the base, we're multiplying it by the height, but we're multiplying by 1/2. I like this slide because it shows you why we do that. If we double the triangle, we will create a rectangle. This picture shows that any triangle is actually half of a rectangle. So base times by height. In a rectangle, we called it a length times by width. We could have called it base and height in a rectangle just as easily. We just multiply those together. That gives us the area for the whole rectangle. And then we multiply by 1/2 because we really just want the area of the triangle, not the rectangle. Okay, so let's practice one. So this triangle is the base is 3 centimeters and the height is 3 centimeters. We multiply those. Well, we've got our formula, so we can just substitute the base and the height into our formula. 3 times 3 equals 9. 1/2 of 9 is 4.5. Again, the answer to this problem is not 4.5. If someone were to ask you the area of the triangle, you would have to say 4.5 centimeters. This time they told us what the units were, so we don't get to just put in a U or call it units. So we're going to say it's 4.5 centimeters squared. Okay, so we need to talk more about triangles. This is a right triangle. It's similar to the example we just walked through. I've marked the base in blue and I've marked the height in green. In this case, the base was the side that the triangle is resting on, and the height was the farthest position left, going up from the base, and it reaches the tallest point on the triangle. So that's pretty simple. To calculate the area, we would just multiply the base, 14, times by the height, 8, and then multiply that by 1/2, and we would be done. But not all triangles are right triangles. And so we need a little practice identifying the base and the height. So let's look down here. The base is pretty simple. It's just going to be the line or the side that the triangle is resting on. But the height this time, the line going from the base to the tallest part of the triangle, occurs somewhere in the middle of the base, but that's fine. It's still the height because it goes from the base to the tallest part of the triangle. Now this triangle up here, the base is easy to identify, the side that it's resting on, but the height this time is shown to the far right of the figure. I have students, the dotted line that goes between the blue line of the base and the green line of the height, that's called the extension. That extension is not included in any of our dimensions. We're not going to multiply that or use that at all when we calculate the area. But I just wanted to show you where and how we're going to be calculating the height. And then we've got one more triangle. Again, the base is at the bottom there, and the height would be the tallest part of the triangle all the way down to where the base would be. But remember the height, let me say this a better way. We always have to have the height drawn in so that it's perpendicular to the base, so that if those two lines did meet, it would form a 90-degree angle. So let's talk about our note again. It said in each case above, and in all cases when we're calculating the area, the height that appears in the formula is a line perpendicular to the base or its extension. And they remind us perpendicular lines meet at right angles. So we're going to use this same idea when we're looking at the parallelograms and trapezoids as well. Hint for calculating. Oh, here it is written out. For most figures, remember to multiply one side by a second side that is perpendicular to the first. This was actually a hint that was given in the geometry packet that I got through the Seeds of Literacy. I'd never actually seen area explained this way, but I thought it was really, really helpful. So if you had that packet, this might be something you would want to highlight for a good hint. So most figures, you're going to multiply one side by a second side that is perpendicular to it. It also goes on to say for a triangle, this often means multiplying a height that may not be one of its sides. Like we just saw some examples of that. Also, remember to multiply 1/2 by 1/2 because a triangle is half the size of a rectangle that has the same dimensions. Okay, a couple of definitions here. Parallelogram. We don't use that shape as often as we do the square and the rectangle and the triangle, so I thought we should probably go over what that is. Parallelogram has to have 4 sides. You're going to have 2 pairs of parallel sides. And parallel sides, if you remember, it is 2 sides, 2 lines that can travel forever in either direction, and they're never going to cross. No matter where we're talking about in the figure, the 2 parallel lines are always going to be the same distance apart. So in a parallelogram, we've got the top and the bottom are parallel, but also the left side and the right side are parallel. They are always going to be the same distance apart. In a parallelogram also, opposite sides are going to be equal, and the opposite angles are going to be equal. There's a special type of parallelogram. If all four sides were equal, that's going to be called a rhombus. So that's basically what a parallelogram is. Let's talk about a trapezoid. A trapezoid is similar and yet it's different. Trapezoid also has four sides, but this time it has exactly one pair of parallel sides. And those parallel sides become the base. So even if this trapezoid was like standing up on end in a really strange position, to identify the base, we would have to find the two parallel sides. And actually, a trapezoid is going to have, it'll be two bases with different measurements. So a trapezoid has exactly one set of parallel sides, but all four side measurements can be different. Okay, so now let's talk about parallelograms and trapezoids as they relate to finding area. So we have to understand how to find the base and the height. For the parallelogram, there we go. There are two bases. We've got a base at the bottom and a base at the top. But the definition of parallelogram told us that opposite sides are equal. So even though there's two bases, they are the same measurement. So we are just going to use that one dimension, that one figure. And then the height, you could find the height in several different places in a parallelogram. I just picked this one because it travels from the base to the tallest point of the parallelogram. But this height over here is exactly the same measure. So for the parallelogram, we would use the measure of its base multiplied by the measure of its height to get the area, just like the rectangle. Okay, now the trapezoid is a little different. The trapezoid also has two bases, but you can see the two bases are not the same length. So we have to deal with those two bases and how to include both of them in our calculations. And then the height, we just have one height. Because our bases are parallel, means that they're always going to be the same distance apart. So there's just a single height. So we will use that height measurement. Okay, let's go through a parallelogram example. So the formula, which you could find on your formula page or you could memorize it, is area equals base times by height. So Tashana, how long is the base in this parallelogram?
4 inches.
The base is actually.
Oh, I'm sorry, 8 inches. I'm sorry.
It is. It's 8 inches. And then what is the height of this parallelogram?
4 inches.
4 inches is correct. I have many students who get confused. A lot of times they will give you extra dimensions, extra measurements in an illustration that you might not need to use. Many students would have tried to use the 5 for the height, and that's incorrect. So you said correctly, the 8 is the base, the 4 is the height. So Tashana, can you figure out what would the area of this parallelogram be?
Hold on. Would the area be 26?
Not quite. Let's go
Okay.
through. This was supposed to be an example. Let me show you. So a little quickly there. To
4.
calculate the area, it's the base times by the height.
Oh, duh.
8 times by 4. And I meant to say this was just a basic math fact, but throughout this lesson, sometimes our numbers get pretty big. I tried, and sometimes we've got fractions. So if you have a calculator today, that would be really, really helpful. Do you happen to have a calculator,
Okay.
Tashana?
Yes.
Yay,
I
good.
actually I actually overthought this situation where clearly it say the area is base times height.
So what did you do? Did you do base times by height and then subtract out something, or what did you do?
I what I did was I did 8 plus 8 plus 10, and instead of just doing 8 times 4.
You want to know what you were doing? That is a super common mistake. And that actually was our lesson from last week. When it's perimeter, we would be measuring the distance around. So it would have been 8
Okay.
plus 8. And then you're right. We would have used this 5 plus 5 more. But that's perimeter. That was that very first slide that I showed you. Perimeter is the distance around the shape. Area, we're calculating the space inside the shape. And
Okay.
area, like I said, is always measured in square units. Yep. So, and it is very helpful to have those formulas. So that's all we have to do. Multiply the base times by the height, 32, and we know it's in inches. So the area must be inches squared. Good.
Before you go, if you could go back to the last slide for just a quick second.
This one?
I just always found it really useful to know that parallelograms and rectangles use the same formula. And if
Absolutely.
you look, Tashiana, if you look at that slice on the left-hand side of that screen by that 5, that yellow line almost makes a triangle that you could slide over to the other side and turn this into a rectangle.
Okay.
And all parallelograms basically are going to work like that because they have those equal sides. And so really, if you think about a parallelogram, it's just a rectangle that's leaning to one side or the other.
Got squished down. And you want to know what?
Okay.
Chris is like me. Let me see how far back I have to go. Chris is like me. I hate that they wrote the rectangle formula as length times by width. And as I was creating this presentation, I found myself for the rectangle writing area equals base times by height. Because in my brain, if I just think that, it really simplifies things. So length times by width, base times by height, basically the same thing. Lost Tashana. Okay. Basically, they're the same thing. Okay, so now let's get back to our lesson. Where were we at? You present. Okay, so back to the lesson. So when we are looking at the trapezoid, there are 2 bases and 1 height, and we have to figure out how to deal with that. So we calculated the area of the parallelogram using the formula. But now to do the trapezoid, it's going to be a little bit different. Because we have 2 base measurements, we actually have to calculate the average or the middle distance between those 2 bases. So there's a formula, and it tells us that we can take base 1 and add that to base 2 and multiply by 1/2. And that's going to give us the average or the halfway point between the 2 bases. I prefer to think of, the distance of this line, the distance of this line, and I ask myself, how long would a base be that's exactly in the middle of those 2 distances? Honestly, most students prefer to just have the formula and plug in the formula, but we'll show it both ways. Okay, So for the trapezoid example, I went ahead and put the formula on the page here, but I'm going to tell you that I would identify my bases. One is 18, one is 12. Identify my height. That's going to be 9 because it's a perpendicular line connecting the two bases. And then I like to think of the number line. To find the average or the halfway point between my two bases, I've marked a 12 and I've marked 18 on the number line. And I say to myself, what value is exactly halfway between 12 and 18? Well, if I do 3 jumps towards the center from the left and 3 jumps towards the center from the right, I see that my average of the two bases is 15. I like knowing that because now that I know what the average or the halfway point of the two bases is, all I do to calculate the area is say 15 times by the height. But like I said before, I've done this lesson with many students and they usually feel more comfortable relying on the formula. So I've got the formula on the page for you. We're going to fill in the dimensions from this problem. So it's 1/2. The height is 9. I'm going to plug that in. Base 1 is 18 plus base 2 is 12. And now all we have to do, you could plug all of that into your calculator. And you would see that the value of the area is going to be 135 feet squared. Okay. Tashana, we were just going over a trapezoid. Fortunately, I have multiple examples of the trapezoid because that's probably the hardest figure to calculate an area for.
Okay.
So let's do the next one. Okay, so this one's just a square. So calculate the area of this square. And we know that the formula that they give on the formula page is area equals side length squared. I personally prefer to just think the area of a square is the length times the width, or even the base times by the height. It all means the same thing. So whichever formula you're using, Tashana, what is the area of this square?
Would it be like, hold on, wait, let me see.
It's a square.
Is it 36?
No, not quite.
No.
It's a, oh, you're doing perimeter again. You added?
Oh,
Okay.
Jesus.
That's okay. So the length here is 9. The width would also be 9. It's a square, so we know they have to be equal.
They are equal size.
Yes, they are all equal sides. So if we multiply the length times the width, what are we going to get?
81.
That is it. 9 times 9 equals 81. Don't forget your units are
Feet
all
squared.
Yep, that's it. Okay. Now this is a rectangle. Go ahead and see if you can calculate the area of this rectangle.
It would be 115 centimeters squared.
You're awesome. That is exactly what it would be. Perfect. Oh, sorry. That was exactly correct. Okay, so let's try the triangle. So remember, triangles, if we cut them into pieces and rearrange them, there's always an arrangement that would make it be half of a rectangle. So we have our rectangle formula of base times height, but we're going to multiply it by 1/2. So for this triangle, why don't you see if you can go ahead and calculate the area of this triangle using the formula.
So would it be half of 96?
It would be half of 96,
Okay.
which is the same thing as 96 divided by 2, if that's an easier calculation on your calculator.
So it'd be 48 inches squared.
Perfect. And you can see, there you go. And there's all the steps. Nice job. Okay, now this triangle looks a little bit different. We've got our base marked and we've got our height marked, but this is one of those times where, you know, the height is not drawn directly from the base. We had to use an extension. But remember, we're just going to ignore those dotted lines. So Tashana, go ahead and see if you can calculate the area of this triangle.
I got 7.5 feet
You're awesome.
squared.
She's awesome and she's fast too. That's it. Okay, now this is a parallelogram. Remember, same formula as we had for a rectangle, similar to the triangle formula, area equals base times by height. Now they've given us some extra information this time. See if you can calculate the area of the parallelogram without getting distracted by that extra number.
So will it be 80 mm squared?
That's it. 80 millimeters squared. That's it. Sometimes it's 10, and a lot of people get perimeter and area mixed up. People see that they've got these two side lengths and they feel obligated to use them. You didn't get tricked. That was excellent. Okay, now this is a trapezoid, and the trapezoid is pretty much the hardest shape that we're going to calculate area for today because it's a little more involved. So Tashana, with the trapezoid, we've got two bases. I don't remember if I marked them. No, I did not. Okay. We've got two bases. One of them is 6 meters. One of them is 9 meters. And then we've got the height of 4 meters. We could follow our formula here that says 1/2, substitute the height of 4, and then we substitute in base 1, which would be 6 meters, plus base 2, which would be 9 meters. And then we simplify that. Tashana, why don't you go ahead and calculate the area of this trapezoid?
Is the area 30 m squared?
That sounds pretty reasonable.
Awesome.
That's it. Oh, you're awesome. Good job. And your steps, I'm sure, look just like mine. This is another trapezoid. On this one, like I said, in my brain, I'm saying to myself, I have one height, and I have to use 12 for my height, but I have two bases. So let me mark all of that. Oops, don't do that. Okay, I've got two bases, but I only have one height. I need to find the average or the midway distance between the two bases. In my brain, I say, gosh, if I add 6 to this 6 inches, I get to 12. If I subtract 6 from 18, I wind up at 12. So I would take the base measurement of 12, which is the average or the halfway point, multiplied by the height. But Tashana, if you prefer to use the formula, I've got it on the screen, or you could use my logic. Go ahead and calculate the area of this trapezoid. How are you coming?
Hold on.
Okay.
So it's one base plus two bases. So would it be 18 plus 12 plus 17?
No.
Okay.
Remember, and you're right, we've got some extra information in this problem too. So the 18, the two bases are the top and the bottom. Remember, the two bases
Okay.
have to be the parallel sides. So we're going to substitute where it says
Be
B1
careful
plus
then.
B2. It must be those parallel sides. But for the
Okay, so it's
height,
18 plus 6.
yes.
Okay.
But for the height, we have to choose between the 17 and the 12.
24.
Remember, the height must be must be perpendicular to the base.
12,
So we have to find the height that uses
5,
this little right
12,
corner. So the 12 will
288.
be our height.
288 divided by 2. So is it 144 inches squared?
That is exactly right. And like I said before, I used my thinking of the average of the two bases was 12 times by the height of 12. Same answer though, 144 inches squared. Perfect.
Hmm.
Okay, now we'll talk about circles. And so,
Yeah.
Tashana, did you do perimeters with me last week? I think you did.
I think I did.
I think you did. So circles, I wanted to review some of the vocabulary just like we did last week.
You not putting him in there. He almost bigger than you. Come on, Gio. Your big brother gonna have you on the ground.
Honestly, I miss those days, both in the classroom and in my household.
I can let him
Okay,
watch a movie with you. All right.
okay. I'm going to go ahead and review the parts of the circle because Tashana, I think you did that with me last week, but just for anyone else who might be watching the videotape. So the circle
Okay.
is the distance around the circle, and it's marked in blue on this diagram. The diameter is the distance across the circle traveling to the center, and it's marked in red on the diagram. And the radius is the distance from the edge of the circle to the center, and that's marked in green. So there's a relationship between the radius and the diameter. The radius is always going to be half of the diameter. So just a little bit of background. So when we're talking about the area of a circle, again, our units are going to be square units because it's how much area is inside our shape. But you can see here, counting the square units isn't going to be very helpful because many of the square units have been split into smaller pieces, and it's not going to be easy to estimate how big those are going to be. So there's a formula, and we just memorized the formula for the area of a circle, and that is area equals pi times by the radius squared. Remember, radius is the distance from the center to the outside of the circle. So pi is another term. I want to just briefly introduce it. That could be an entire lesson all in itself. Pi is a relationship found between the circumference, the blue line around the circle, and the diameter, which is the red line across the middle. Someone many, many years ago figured out that whenever you take the distance around a circle and divide it by the distance across the circle, you always come up with the exact same number. And it's approximately 3.14, but it goes on forever and ever and ever. So when we talk about pi, we usually substitute the approximation of 3.14 or the fraction of 22/7. But honestly, if we want to be precise and talk about exactly the number that is pi, we just use this symbol. This pi symbol is a number. We're not going to be practicing writing our answers with that number within the answer this time. That would be a lesson for another day. Okay, so we're just going to calculate the area, and someone is going to tell us the formula for the area of a circle is area equals pi times by the radius squared. And for pi, we're going to substitute 3.14 today so we can come up with our answer. So let's go ahead and try to calculate the area of this circle. So I have Lana now too. Hello, Lana.
Well,
How are you doing?
I'm pretty good.
We've been calculating the area of lots of different geometric shapes. We've worked our way up to the area of a circle. And so the formula is area equals pi times by radius squared. So we can just substitute the values from our figure here in order to calculate that area. So let me see. Tashana, did you do the perimeter lesson with me last week? I mean, Lana, you did the perimeter lesson, didn't you?
I think so, yes.
I think so. Okay. If you want to try to calculate the area of the circle, go ahead. And Tashana, are you back? Are you calculating the area?
Yes.
Okay. So go ahead and see if you can calculate the area of this circle in the figure.
That's a song? That's a song? No, it's just a movie, Dean. You put down your Oh. Yeah.
Oh, and Lana, we said earlier a calculator would be really, really helpful in this lesson. So
Oh, okay.
definitely feel free to use your calculator when you're doing these types of calculations.
Okay.
Would it be 31.4 inches squared?
Not quite.
Not quite.
Let's give Lana a chance. And
Oh,
Tashana,
the area.
but the where it says radius squared, remember that's the radius multiplied by itself. So Tashana, have you figured out what is the radius of this circle? Do you know?
Is it 20?
No. Remember the radius.
Oh, go ahead.
What is it? What do you think it is?
It's 5.
It is 5. Radius is half the distance of the diameter. So we would substitute 3.14 where it said pi. We would put 5 in for the radius, but now we have to square that. And so that's the same thing as saying 5 times by 5.
Okay, so it'll be 3.5 times 25.
3.14, yep.
0.14 times 25. 78.5 inches squared.
So Lana, what do you think? What are you coming up with? And Tashana, tell me your answer again.
75. 78.
Wait, where's Lana? There's Lana. Lana, that's perfect. Tashana, you are super close. Might be a calculator issue. It is, multiply that out, comes up with 78.5 inches squared. So
That's
Lana,
what I said.
Oh, is that what you said? Oh, I'm sorry. I heard 8.5. I was thinking, okay, I'm sorry. I misunderstood you. So that's it. That's perfect. Lana, we were talking about, because the area is the space inside of a figure, and like we just looked at, there we go. We measure area in what we call square units. And so whenever you give the answer for area, you have to include, the units squared. So the correct answer would be 78.5 inches squared. Okay. I have some of these, the next couple I consider challenge problems, but I think the two of you guys can handle them. First one is, if 6 people share a large pizza that has a 14-inch diameter, of course, I can't see all that, how much pizza will each person get? Round your answer to the nearest square inch. This was a really complicated problem. So let's just start off calculating the area of this pizza, and then we'll deal with getting one slice. We'll deal with that later. So everyone, go ahead and calculate the area of the pizza. Lana, that looks pretty good. Tashana, how are you coming?
Lost.
Okay, let's take it one step at a time. Lana's showing me her answer, and I'm trying to remember all the different steps and all the different numbers.
Okay, well, can I say how I did it?
Yeah, go ahead, Lana. Let me see if I can get the clicks to start working again for me. Okay, go ahead, Lana, explain how you did it.
Okay, well, we know that whatever the number that we have in a diameter, we need to it should be half of whatever the number is. So I changed it from 14 to 7. And then 7 squared is 7 times 7, which is 49. And then I multiplied 49 times pi, which is 3.14. And that's how I came up with that answer.
That is
7, the diameters, which is squared.
That's perfect. That was an excellent job. Now, but there's more to this question. And a lot of people would say, oh, well, the answer is 153.86 inches squared. But back to the question, it said, if 6 people share a large pizza that has a 14-inch diameter, how much pizza will each person get? And then they want us to round our answer to the nearest square inch. So if 6 people are going to share that pizza, figure out how much pizza each person gets, and then practice rounding that answer to the nearest square inch.
So maybe that is divided, the answer is divided by 6. So
Perfect.
maybe it will, what, they get 20, 26, what, square inches?
That's it. That's it. Let me just double check the math. 26 inches squared. That was perfect, Lana. Tashana, did you kind of figure out what we were doing on that one?
Yes.
Okay, good. This next one is weird. It was just such a strange problem. I thought, it would be worth going over. It says, refer to the drawing below. Choose the whole number that is closest to the result of dividing the area of the square by the area of the circle. There is so much going on here. Let's all of us go ahead and calculate the area of the circle first. So everyone calculate area of the circle.
So would the area of the circle be 12.56?
I think that sounds familiar. So radius was 2. So the area of the circle would be 12.56 inches squared. Nice. So we've got our first number that we need. Now we need to calculate the area of the square. So everyone go ahead and calculate the area of the square. And look, I did it. I wrote base times by height because in my
64.
head, that's what I think. What was it?
64 inches.
That is it. 64 inches squared. Okay, now listen to what they want us to do. They choose the whole number that is the closest to the result of dividing the area of the square by the area of the circle.
Okay, so
You're going to have to write that division problem.
0.56 divided by 64.
We'll be careful. Area of the square divided by the area of the circle.
0.56.
Square divided by circle.
So I get 5.09. So
You're super close.
if you round it, then it should be 4.
We've got
No.
some kind of a calculation error there, I think. So try it again. So let me see. We had to write the problem.
64
divided by 12.56.
12.56.
Okay. And what does that equal?
I got 5.09554141.
And it could be that, let me check out my calculator. It could be that I made a mistake. Our numbers are really, really close. Let me see. 64 divided by 1, 2, 6. You're correct. I put
Okay.
down 5 1/3. I came out with 5.3333 repeating, but you were actually correct. I think, was it Tashana that said that?
Yes.
Nice. Nice job. It actually was 5.0955414. But
Okay.
the question says they want us to find the number from these choices over here, A, B, C, D, and E. Which number is the closest to 5.0955414?
5.
Lana, what do you think?
I'm still lost at how you get the other numbers, so.
Okay. So Lana, let me see. Did you get the area of the circle?
I came up with 314. I don't know how those other numbers came in.
Okay. So look up here at the top of the screen. So instead of pi, I substituted 3.14. And then the radius for the circle was a 2. So I
Mhm.
substituted 2, and we're going to have to square that. So it's really like 2 times by 2.
Okay.
So multiply that together and tell me what you get for the area of the circle.
I get it. Okay.
Okay, did you get that one? Okay,
Yeah.
perfect. So now the area of the square, did you get that one okay?
Yeah, the 8 has 2 times the length and the width. So that, yeah, I got that. That was 64. I just didn't get how you came up with the 12.56. So I
Okay.
was like,
I was just fixing my blender on that one that Tashana caught me in. Okay, so now you have to take, let's get caught up again, the 64 divided by 12.56. No, looky there. This time I got 5.0955. Is that what you got, Lana?
I might have hit the wrong button. Let me do it again.
It's easy to do. That's why I said for this lesson today, we really need a calculator. So clear it all out. 64
Okay.
divided by 12.56. That's it. That's exactly right. But now the question, they still aren't satisfied. They want us to choose the whole number that is closest to the result of dividing the area of the square by the area of the circle. So our 5 choices are over here to the left. So is it closest to 4, 5, 6, 7, or 8?
It's closest to 5.
5. And that's it. Perfect. Okay. Now, that is the end of where I wanted the lesson to go today. I have a little review. We'll do the review in just a minute. But it's making me think. I had several more problems prepared that are challenge problems, real similar to what the last 2 that we just solved. I'm thinking next week, one of my lessons that I'll do will be maybe perimeter and area advanced problems or something. So we'll do more next week. But let me go to our little review for today. Okay, so in review, it says match each formula on the left with the area it represents. Each choice can only be used one time. So we're going to start with base times by height. That is the formula, and Lana, this is going to be a challenge because you weren't here for the whole lesson, but let's see how much you know. You seem pretty good with area. Base times by height, what is that going to be?
Base times height. That seems more like that's a woo. It's between a square and a rectangle. I'm just gonna go with a square.
You want to know what?
It's a rectangle.
In my brain, I think of the formula for the square and the rectangle as base times by height. But technically on your formula page, it's going to say something a little bit different. So let's skip that one and we'll come back to it in just a minute.
Okay.
So let's do number 2. 1/2 of base 1 plus base 2 times by the height. What's that the formula for?
Lord.
Now that's the one I want to say right when you got on. Oh no, you came on right when we were doing the circles. Oh, that one's going to be tough. Okay, so I'll go ahead. That one is going to be the trapezoid. So we'll start back up here. Base times by height. Technically, that's the formula for the parallelogram. It's also a formula that will work for squares and rectangles. And so I'm happy that you said both square and rectangle. This one is for trapezoids, because on trapezoids, you've got 2 base measurements and you have to find the average of those 2 base measurements. So in just a minute, Lana, I'll take you back and I'll show you just a couple of those quick examples. The side length squared, that's technically the formula for finding the area of a square. Same thing as base times by height. Now, how about 1/2 base times by height? Do you have any idea what formula that would be?
More than most likely, that's the triangle.
Perfect. How do I get my thumbs up? That is the triangle formula. And then pi r squared. I know you were with us for that one.
That is the circle.
That is the circle. And then length times width is just another way of saying base times by height, but it's only used for the rectangle. And so that is the final one. Okay. So I just want to show you, I'm not going to go back through the whole lesson, but I do just want to show you the trickiest parts. So the parallelogram and the trapezoid. Those, we don't see those figures as often. And so usually those are the formulas that my students have a harder time calculating area for. So for both of those figures, we have to find the base and we have to find the height. Now for both parallelograms and trapezoids, we have two bases. In the parallelogram, the bases are the same length. So we just use that number. You know, we have our distance for base. And then the height, we always have to calculate the height. The height will always be a perpendicular line, which means a line that goes up at a right angle to the base. And so we take the highest point of any figure. In a triangle, you know, that's going to mean something different than in a parallelogram. So for the parallelogram, you're going to take the base times by the height to get the area. The trapezoid is tricky though, because we have two bases. So we have the shorter base and the longer base. And so we have to find the average distance between those two, or the halfway point. In the formula, oh, and then the height, we just have one height for the trapezoid. So the formula, parallelogram, here is an example. You take the base times by the height, and that one was going to be, 32 inches squared. But the trapezoid is really tricky. So we've got two different bases, so we need to come up with one measurement that represents the base. And so in the formula, they tell us to add the two bases, so 18 plus 12, which would be 30, and then divide that by 2 to find the halfway point. So what would 30 divided by 2 be, Lana?
15.
15, yeah. And so 15, I think this is the one where I had the number line. Do I have my number line? There it is. 15 is the halfway point between 12 and 18. And so that's the value we could use for the base. And then the height value would be 9. Most of my students, though, usually say, I would really rather just use the formula. And so that's fine. We can just plug in the values. 1/2 times by the height was 9. Base 1 was 18. Plus base 2 is 12. Plug all that into your calculator. And you come up with the answer, 135. And whenever we're talking about area, we always talk about our units squared. So that was just a quickie. But I'm going to go ahead and end the lesson now because we've gone a little over an hour. But next week, I'll definitely have challenge problems for both the perimeter lesson and the area lesson. So you can have a chance to practice more of those kinds of things. Any questions before we go?
No.
No?
Oh, I missed so much. Oh my God.
You're doing great. You're showing up. You're doing fantastic. Plus, Lana, you have a really good aptitude for math. You pick things up quickly. And that's not the typical student. So you're the kind of student who could show up halfway through the lesson and still kind of reason it out and make sense of most of what was said. So, but if you want, next week we can practice some more.
I would love to.
Fantastic. We'll do it. And I'll throw in some of those perimeter problems because people are always getting area and perimeter mixed up.
Thank you.
Cool. Thank you. Have a great day.
You too.